Welcome to this presentation. I intend to go through frequency table or distribution table, which we say it's a listing of possible values for a variable together with the number of times they appear in the data or relative frequencies for each value. There are two types of frequency tables. One for ungrouped data, which we refer to as the simple frequency table, which I intend not to go through because it's well explained in the notes, but just maybe to just highlight a bit what happens when you are dealing with a simple frequency table. All you need to do is to take the data that you have, and as it is, you organize it into a table. For example, if I have a simple table, a simple data here with the numbers 1, 3, 4, 1, 2, 3, 5, 1, and another 2. And I intend to present this one in table form. All I'll do is have a 2-column table, or even 3, where I have my observations, call them X, where I may have the tally mark here. I have the tally mark, and then finally I'll have the frequency column here. So I have values represented are 1, 2, 3, 4, and 5. And all I'll do is go to my data here, enter 1, it's appearing once, so I present it with a stroke, another one, another stroke, but I can follow the order so that I don't leave any out. So once I go through the first one, then I go to the next, which is 3, and I enter 1 here, represent with a 1, 4, I cancel, represent with a 1, 2, I cancel, represent with a 1, 3, I cancel, represent with another 1, 5, I cancel it, represent with 1, then another 1 here, represent with another stroke, and then finally 2, represent with another stroke. So in the end, I'll be able to count how many times each one of them appears. And here, for example, I have 1 appearing 3 times, 2 appearing twice, 3 appearing twice, 4 appearing once, and 5 appearing once. So in the end, you can see I have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you add these values here, this is 3, plus 2 is 5, plus 2 is 7, plus 1 plus that, we get 9. So in the end, I'll be able to get my total frequencies, which is 9. So that is what we call a simple frequency table. But then we have the other one where we have the grouped data. Now, if the data is too large, the values are very many, and they are also very widely spread. So what you need to do is to prepare what we call a grouped frequency distribution table. And we have two formulas or two methods that we use. One of them is the exclusive method of classification, which we are now talking about grouping or preparing grouped data. So I have grouped data here. This is for grouped data. And I have a simple example here with these values. They are all 20. And all you need to do is, again, just as we have done with the simple one, prepare your table. So in my table here, I have the first column. And because it is exclusive, remember what we said, exclusive method of classification means you have the upper limit of each class is not included in that class. It is excluded, but it belongs to the next class. And that's why you can see in this data, I have prepared two columns, one with the range 5 to 10, 10 to 15, 15 to 20, and so on. But the second one, I have included the inequalities to make it clear. So for the first one, we are saying this time for the first range, 5 or first interval 5 to 10, we are saying the time is greater than or equals to 5, but strictly less than 10, because 10 is not included in this class. But 10 belongs to the next class. So you can see here we have 10, and then it is greater than or equals to 10, but strictly less than 15. Because now 10 belongs to this class, not to the first class. 15 again belongs to the next class. 20 belongs to the next class, and this is what we call the exclusive method of classification. So just as we have done here, all you'll need to do is start from the beginning here. For example, go to 20, you remove it from your data, but represent it with a stroke in your tally mark column, and you continue doing all that. And you can deal with a group of 5, 5. So once you have 4 of them, for example, for the interval between 15 and 20, the first 4, then you tie them with the 5th one so that you can have a bundle of 5, and then finally you will calculate the frequencies. Now, when you're preparing the grouped data frequency table, you can also decide to have the cumulative frequencies, and these are the less than. Remember, there is what we call less than and more than. So these are the less than cumulative frequencies. So you can have them here where you're adding them cumulatively. This is 1. Then 1 plus 4 gives you 5. 5 plus 4 gives you 5 plus 6 gives you 11. 11 plus 4 gives you 15, and so on until you get all of them. You can also include what we call the class midpoint for each class. So you have the class midpoints where you add 5 plus 10 is 15 divided by 2. 10 plus 15 divided by 2, and so on and so forth. So that is what we call the exclusive method. Now, number 2, we have the exclusive method of classification. Now, for the exclusive method, again, the inclusive method, we can see this is inclusive. That means both the upper and the lower boundaries, or the lower and the upper limits, are included in that class. So this 9 belongs to this class. This 14 belongs to this class. 19 belongs to this class. So what does that tell us? That this data now is not continuous. The other one was continuous. For example, you can see 25 to 30, 30 to 35. But here we have 25 to 29. There is a gap. 30 to 34. There is a gap as we move from 29 to 30. So it is inclusive, and therefore it also leaves a gap as you move from one class to the other. So in this case, what you need to do is you follow the same order of having a tarmac column. You have the corresponding frequencies. You can have the corresponding cumulative frequencies. The less than, these are the less than cumulative frequencies. Of course, we look at the greater than when we come to the cumulative frequency curve. So you have the less than cumulative frequencies. We have the class midpoints. But now, because of further use of this data, you can include the class boundaries. Remember the boundaries, we say they give you continuity of your data. So what do? You adjust your class limit by adding a plus or a minus. So you add a plus, that is to the upper limit. A minus, you subtract from the lower limit, half of the lower unit of measurement. So for example, here, if you take 10 minus 9 or 15 minus 14, it will give you the least unit of measurement here, which is 1. Then you get half of 1, which is 0.5. So you subtract 0.5 from the lower limit, each one of them, and you add the 0.5 to the upper limit for each one of them. So in that case, you end up getting the class boundaries. Remember, this is what you will use when you are computing. For example, if you are computing mean, that is median, or you are computing the mode, or you are computing the quartiles, or you are computing the percentiles for a grouped data. Remember, grouped data, or you are plotting the frequency, the cumulative frequency curves, both of them, more than or less than, and you're also drawing or constructing the histogram. So you use continuous data for all these. So you'll have to use the continuous data. In other words, you'll have to make reference to the class boundaries. So they are very, very important when you're doing these computations. That will be our next video. Thank you very much, and I wish you the best as you continue revising. Kindly go to the class note, do the revision, the questions that are there, and also go to the platform and get access to the revision exercise on this lecture 2 concept, or the lecture 2 notes, so that we are able to catch up. Thank you very much, and thank you and good day.